12-volt batteries. I think it's 12, it might be 8. It's something like that. But one of the bigger batteries, and we actually took a little milk crate, or almost like a pencil crate like this, or a little crate that had a big enough hole. We took a copper rod, ran it through it, and we had a Hawaiian punch can. And we actually put pieces, and we had 3 wires going across. And what we did is we put pieces of tape, electrical tape on the can in certain spots. And that way when you spun the can, when it was hitting that tape, it would go off. And when it touched the can, it would actually make the light light up. So you can make it work like a traffic light.
Yeah.
Yeah, we need something like that.
But that's pretty cool. But let's think about the bulb and the battery and the wire. What is going on here? What forms of energy do we have? Do we have potential and do we have kinetic energy? We have chemical right here. And there is kinetic energy. Is there potential energy?
Yes, a lot.
Sure there is. When we're right here, if this light is not on, there's potential energy here in our battery. Okay, what is our chemical energy transformed into? Hush. Try it. Don't be afraid of being wrong. It's all fun. What happens here that goes to the light? Think about it. Just say it. Go for it. Say a bunch of things. If it's wrong, we'll keep going. Close. Chemical energy changes to... They just helped you out. Electrical energy. So then we have electrical energy coming through our wire. And I don't know if y'all have ever noticed, but on a light bulb, there is a hot, or your power here, and actually your negative or your ground touches the side. So that's why when you look inside a socket, you have that little piece, and I don't know if y'all know, but a lot of times that piece will bend up, and you have to actually turn your light off and bend it back down to get it to touch the bulb, to make contact. Okay, when we actually turn on this light, and we make contact here, what types of forces are we getting with the light?
Power.
Well, we know it's power. Power is energy. Heat. We have heat. What other types of energy do we have? Radiant. We have light. So, there are 1, 2, 3, 4 forms of energy just in that system. Ain't that pretty neat? Pretty cool, huh? Okay. Next, Mr. Strange, why don't you work with them trying to, we can do the, let them draw something to show potential and kinetic energy. If you wanted to give them a minute to think about some of the things they can do, and you can demonstrate some of the things you were going to demonstrate, and I'll help you do that.
The ball's at rest, right? What does it have? Talk about it.
Potential.
Good.
This balance.
Okay, but what happens when you move it? Right? Okay, so if I have it here, comes this here. When's the potential kinetic energy?
When you drop it, it falls.
Which is? Guess what right now? We've got potential sitting still. Remember, potential is sitting still. Kinetic is moving, right? Okay, so what if I drop it up here?
Loud. Loud.
Does it bounce higher or?
That's more.
See, I'm dropping it above my head, right? I dropped it here a while ago. What happens? Where'd it come up? Now, okay. Now what about now? Has more, right?
So the higher you get it, the more potential it has?
Right.
Who has more potential energy? Him holding that basketball here, or this guy 55 miles above the Earth's surface? Right. The only time I think I've ever seen a human being have more potential energy as this is y'all guys 5 minutes before the bell rings. I think y'all build up a good bit of potential energy in, don't y'all? Ready to rip and go home. Keep going.
Y'all think of things that's got potential for kinetic energy?
Think about the playground.
Yeah, think of a playground.
Draw us some things that have potential and kinetic energy.
Y'all draw it?
Yeah.
See who has the best swing. Best swing.
And show us when there is potential and kinetic energy. Show us at what point.
Draw it.
And there are a lot of other things, you know, that have energy. We're just kind of touching the surface. So, do what? Oh yeah, sun has a bunch of energy. Oh, slide. We have a lot of different forces. Y'all been dealing with a lot of balanced and unbalanced forces. So when we do that, we have friction, we have gravity. Ain't nobody gonna make fun of your swing. We're gonna be proud of you no matter what you do.
You got your swing drawn?
No, not yet. I do.
That's another thing. If we would have had a bigger spot, I was going to say that mechanical energy, we have potential energy when we're down here, and then we see if you jump the highest, that would be kinetic energy. So that would be another thing. And then you have another thing that we didn't discuss that we needed to discuss was the law of conservation of energy. Does anybody know what it is? When we conserve something, what does that mean? So, what does that mean about energy? It cannot be created or destroyed. It only can transform or move to a different object. So, in other words, just like you were talking with balanced and unbalanced forces, when we hold the ball, the law of conservation says that we cannot create or destroy energy. So when he drops the ball, there are forces that are acting against it as it's going down. Gravity's pulling this way, but we also have air resistance coming up, right? So the ball isn't going to come all the way back up to us because it's releasing some of its energy. So energy cannot be created or destroyed, but it can change forms and be transferred to different things. So,
Which one y'all think will bounce high?
This one.
Now, a basketball?
The small one. The small one. The small one. The small one.
Basketball.
Small one.
Drop them both from here. Okay, y'all help me out here. You ready?
1, 2, 3.
Basketball.
Basketball.
We can have more weight.
more weight.
What if I drop it from here?
Basketball.
Basketball.
What's going to happen now?
Small one.
You ready?
Yeah.
Ball again.
Okay.
So, what is potential energy? Let's go over one more time. What's your name? Crystal. What is potential energy?
It's like when you're
Relax.
Okay.
What do you do when you go home and you're tired?
You lay down.
Take a rest, right? What energy it is? It's not moving. It has the potential to do work, but it is at rest. Okay, what is kinetic energy? Who had their hand raised before? I think it was Heidi. What is kinetic energy?
Something in motion.
It's energy at work, so it's moving. It has energy and it's using. Let's see. What is chemical energy? How is it produced? bonds. And when there's a reaction, those bonds break, and that's where our energy is released. So that's what I want you to make sure to tell your parents. When you get home, don't be like, well, these two chemicals mix and they make lime. Because that's not right. Them two chemicals mix and cause a reaction that splits molecular bonds, which releases energy. And it's pretty much the same with nuclear energy. When you are splitting that nucleus, those protons want to spread apart from each other. So it's like, woof, a big release of energy. And actually it uses more of its energy than I think any other type of energy. A lot of other energies, thermal energy and stuff like that, we waste it.
Sorry, we got 3 that need to leave.
4.
Alexander.
Okay, let's see your swings. Okay, where's your potential energy and where's your kinetic energy?
When you eat, can you get
When you eat,
yeah.
Heidi had a good question.
What you would do is right here, you would draw the swing sideways and show it going forward and
I
backward.
believe you would.
And there's one thing I really want to point out.
Ask him a question.
So I did.
When you swing,
Just don't, you got a good question right here.
okay.
What you got, Heidi?
Like when you eat, isn't there like chemical motion wherever you
Digestion.
Yeah, there is energy released in digestion, and our body actually
Convert.
produces very important chemicals like ATP that help us drive each one of our cells. And so digestion uses enzymes, but that would be a form of chemical energy itself. So there is also, I wonder if there's heat, or surely there's heat released also. So
We eat to get warm.
when your enzymes that you have in your belly digest your food, there is a lot of energy being produced and released at the same time. But one thing I wanted to point out before we have to go is when you have your swing, when do you think we have potential and where do we have kinetic energy? When we start off, when it's at its peak here, it actually stops, right? So it's got as much energy actually. Let me see one of those strings. This one has. So, Mr. Strange had this, and we're going to use it as a pendulum or a swing. A pendulum, it swings from a point, right? So when he's holding that, and he pulls back on it, right now it has a lot of potential energy. Right? When he lets go, there's our kinetic. But, is there any potential energy left as it swings?
Yes.
Where is it at?
When it goes up here and stops a little, and then it goes back here and stops a little.
Did everybody hear that?
Mm-hmm.
So we have potential energy at both ends because it gets to a peak and it'll stop before it goes back the other way. So we have gravitational potential energy here, and we have gravitational potential energy here. And in the middle where we have our dotted lines, that's all our kinetic energy. And actually, if we want to get to it, in certain points, it would still have an amount of